Once again, I thank you very much for inviting me to deliver this lecture. Today I shall be speaking on advances in the state of practice of geotechnical investigation in India. So my thrust here is on the modern geotechnical investigation techniques and the new techniques which have become quite popular in the country. As you know, geotechnical investigation practice is rapidly evolving. We had the classical era of 𝗓𝗏𝗃, Peck, Horslevs, Kempton and other masters. Now the 21st century is a little different. Developments and demands of the 21st century, the geotechnical practices have led to a greater emphasis on in situ tests, advanced testing tools, digital data acquisition. This is becoming fairly important now. And we are facing increasingly complex nature of the problems. These present challenges to the new generation of geotechnical engineers, and they have to work out solutions to complex problems. So what are the problems, what are the challenges? The conventional methods, they are not good enough to design complex modern structures like tall buildings, metros and railway structures, major bridges, refineries, thermal, nuclear, solar power plants, dams, hydraulic structures, etc. So the thrust today is on developing more realistic design parameters, encroach on the factor of safety. A conventional factor of safety of 2.5 or 3 is just not enough. But you want to enhance the factor of reliability. So if you can be more confident of your design, obviously you can push down the factor of safety. So to be able to estimate realistic design parameters, today because very powerful finite element softwares are being used, so the input has to be more reliable. Because as you know, garbage in, garbage out. So if the quality of the input data is poor, obviously the output is not going to be that great. So what are the aspects that need to be addressed here? You must perform a variety of in situ tests and laboratory tests, so that you can predict parameters from different tests, develop correlations between various parameters, enhance the precision of the tests, the quality of data acquisition, and the reliability of the data. And of course, the most important thing is to use local experience regarding the soil behavior to minimize the uncertainties in the selection of the design parameters. So there is a great need for upgrading the conventional investigation methods. Earlier we used to talk only about boreholes, but now there are several new technologies available which can enhance the quality of the data. So some of these tests I will be presenting here. This is by no means the complete list. The first one I will be talking about is SPT energy measurement. You would like to standardize your energy transfer to 60% energy being transferred to the SPT anvil, so that you can standardize the N values. There has been a lot of complaint over the years that different parties, different agencies do a investigation and you get different SPT values at the same site at almost same location. So you can remove all those errors with energy measurement. Then I will talk about electric cone penetration test with pore water pressure measurement. Then also the seismic cone penetration test. The other important test which helps in getting the realistic parameters is pressure meter test. Also a geophysical test like electrical resistivity test, electrical resistivity imaging, and seismic tests like cross-hole seismic tests, seismic refraction tests, SASW, MASW, and all these. I'll be just giving you an introduction to all these various tests and also presenting a case study demonstrating the benefit of these technologies. So let's look at some of these modern technologies being used in the country now. The first one I will talk about is the SPT energy measurement. So energy calibration normalizes the energy transfer to the SPT sampler so that you can remove the scatter in the values. Thus, you enhance the reliability of the data. So what you should be doing is standardize it to 60% energy transfer. That is called N60. So what the SPT analyzer system has, it has a 0.6 meter long drill rod instrumented with 2 strain gauges and 2 accelerometers. You insert it at the top of the drill string. The sensors on the rod are connected to the SPT analyzer, which is basically a computer. With the strain gauges and accelerometers, obtain the force and velocity signals for calculation of the energy transferred to the drill string for each hammer blow. So this is the so this is the drill rod which I am talking about, and this is the SPT analyzer. So this is a typical output here. So this was one typical site which we had done in Noida. So 3 different depths the energy transfer was measured, and an average you can see 71% energy was being transferred. So now if your SPT value is say 20, then you'll have to correct it for 60% energy transfer, so it will increase a bit. So 71 divided by 60, so that would be the increase. The CPTU equipment, the equipment you can either use anchors to take the reaction, or you can have a crawler mounted rig. This is the schematic sketch of the piezo cone. It shows you the position of the various sensors. There is the pressure sensor, then there is of course the there is an inclinometer to measure this thing, and then pore water pressure is measured. So there are different types of cones are quite popular, and the most
presentation is not visible.
Sir, excuse us, I think you are not in presentation mode. I think a screen sharing is not working. I think some problem.
Can you see the presentation in the normal mode?
Sir, we are seeing very small.
No, sir, no.
Should I stop sharing and then?
Yes, stop sharing and then continue, sir. Then continue. That will be better.
Is it now visible?
Yes, sir.
Yes, now it is visible.
Yes, sir. Yes.
Now it's okay.
All right. Now can you see the screen?
Yes, sir. Yes, sir.
Yes, sir.
Okay, great. So you have the CPT system using anchors as well as a crawler mounted rig here. This is the schematic sketch of the piezo cone. The standard cone which is used, this has the pore water sensor just above the cone tip. This is called the U2 position. And cross-sectional area of 15 centimeters square is used. So what it does is that it records continuously the penetration resistance, frictional resistance, and the pore water pressure during drilling. So data collected is electronically connected to a computer. So it eliminates human errors. And because it does continuous recording almost every 0.1 meter, so you have a huge quantity of data. It is advantageous for better assessment of strata conditions, for liquefaction assessment. The test method is as per the ASTM. Now it is being incorporated in the IS code. The draft code is been prepared. It should be released very soon. So cones with cross-sectional area of 10 square centimeter and 15 square centimeter are popular. For the CPTU, the 15 centimeter is probably better. There is a porous element for pore water pressure measurement just above the cone. And the advantage is that you can also add other sensors to measure shear wave velocity. This would be the seismic cone. Also the thermal resistivity, the electrical resistivity, etc. So these kind of technologies are available. So that's the electric cone penetration test. You can see how it works with the hydraulic pushing system. You have the pore water pressure being measured here, and you make sure with an inclinometer you measure it vertically. So you have a continuous push. Every 1 meter you add the rods and go ahead. So this is typical cone penetration test results. You have the cone resistance, the sleeve friction, the pore water pressure you can see being measured here. This is the water table at this level. The friction ratio is the sleeve friction divided by the cone resistance. And you can interpret the soil behavior type. Robertson has developed the concepts, and soil behavior type can be measured. Now I'll come to the seismic CPT. So the equipment is basically the same. Only thing is that there is the seismic sensor which is attached above the cone. And this is the data acquisition in progress. So this is what we do. We fix the cone on the ground, and then you have a wooden plank. You hit horizontally to get the. You have two sensors at fixed distance, usually 0.5 meters. And you measure the time arrival between the two, and the difference will help you work out the shear wave velocity. Once you have the shear wave velocity, shear modulus, all other parameters can be computed. So this is the data acquisition system for the seismic CPT. You can see how the data is being. So you directly you get this from the two sensors, and then you rephase it, and so that it overlaps, so you know how good or bad your data is, and you proceed. Now I come to the pressure meter test. This is the Menard pressure meter equipment. The control panel, a gas cylinder helps you maintain the pressure, and this is the probe. You can see that. So the Menard pressure meter test, dilatometer, these are finding lots of applications. The Oyo dilatometer is there. There are other kind of dilatometer equipment. The Menard pressure meter is done in pre-bored boreholes. Self-boring pressure meter is usually not yet available in the country, but maybe it will come soon. We don't know. Parameters that can be determined from the test. There is the limit pressure, the deformation modulus, in situ horizontal stress, unconfined compressive, that is the shear strength, pre-consolidation pressure, OCR, all this you can determine from the test. So these are the probes here. This metallic one is for high pressures in rock. The one Maynard pressure meter usually carried up to 80 bars. It is suitable for hard soils and weathered rock. The one with the rubber probe, this is used in soil, soft to medium soils. Equipment with capacity up to 200 bars is also available. The 200 bar equipment is for medium to hard rocks. But since bearing capacity and settlement is usually not a problem in hard rocks, the 80 bar equipment is suitable for most applications. The standard diameter of the probe, AX, BX and NX, NX is more popular. Typical results of the pressure meter test. This is the field curve, pressure versus volume. So you can see here the maximum volume expansion is 900 ml for the NX probe. Initially the probe is first expanded in air, and the stiffness of the rubber parts itself you have to subtract out from the field curve, and also you expand it in the in a pipe, so the rigid pipe, and you will remove the expansion of the hoses also. So this would be the final corrected curve which you get. So this maximum pressure to which the sample, the soil, it fails here. So this is called the limit pressure. The slope of this graph, this is a function of the modulus of elasticity or the deformation modulus. This is the pseudo-elastic part of the curve. So this is the limit pressure and deformation modulus versus depth for a typical project site. So here you can see here 5 tests were done, and all the tests have been plotted here, and the design profile has been selected. Also you can calculate the horizontal stress, because the pressure meter involves expanding the probe radially. So what is the horizontal stress at that level can be determined, and this is the standard graph which I had made, assuming a K0 value of 0.55. So you can see here at this particular site, the actual K0 is probably slightly higher. So you can actually determine the horizon, the operating K0 at the particular depth using the pressure meter. So you can use this for design of the retention systems and the diaphragm walls if you're doing deep excavations. So you have much reliable and enhanced parameters for design of the retention systems. I will go on to the geophysical test. This is the electrical resistivity test. Standard Venner configuration is used for doing the electrical resistivity test. This is the Venner configuration. You have 4 electrodes being embedded into the ground. Also the Schlumberger configuration is used for groundwater surveys. This is a typical case where we had used this test to determine the stratigraphy. So we plotted the electrode spacing versus A by rho A, and we could identify where data changes were occurring. So the data was analyzed with the inverse slope method to correlate it with the stratigraphy. Now, more advanced technologies are now available. This is the electrical resistivity tomography or imaging. So here you use 50 to 100 electrodes, and using this software you can interpret the various layers here using the electrical resistivity tomography. Seismic refraction test is another test which is a very useful test. This is also done along a line, and this is a Delhi Metro project where the seismic profile was matched with the borehole data. We found a reasonably good match. This is the SASW test, similar kind to MASW. This was used for the Commonwealth Games village in Delhi for the liquefaction analysis. So with this background, I come to the case study to demonstrate the application of these tests and what benefits you can get by doing all these tests. So this particular project is in Gurgaon, Haryana. The plot area is 8.9 acres. So high-end towers, 5 towers being constructed, 40-story, and 2 towers are 30-story. All are having 3 basements. So, and also some other facilities like commercial buildings and various other things. So let's see what the scope of work was. So here there were 5 boreholes to 60 meter depth, 3 boreholes to 30 meter depth. Because we used 4 rigs to do the tests, so there were 4 SPT analyzer tests. 15 electric cone penetration tests were also done, and pressure meter tests were done in 5 boreholes. 2 cross-hole seismic tests. So it was a very large scope of work which was done for this particular project. So that's an artist's impression of how the towers will look like. Presently it's under construction. This is the layout showing the various towers and the location of these various tests. This is the plan. Now I have the summary of the borehole profiles. So if you can see here, I have this borehole 1 to 7, and then I have the strata interpreted from some of the CPTs. And all these numbers you see here, these are the SPT values which are corrected for energy transfer. And in the CPT, the interpreted N6 values. I have a complete profile of how the soil characteristics are there across the site. So this is a site very close to Delhi in the Indo-Gangetic alluvium. So what you are getting here is sandy silt of low plasticity with some minor sand zones. Groundwater here 3.5 to 5.9 meter depth. This is the profile here. So typical SPT data energy measurement, you can see an average of 73.5%. So what has been done is that normally below 10 meters we do 3 data acquisitions. Each data acquisition, so about 15 or 20 blows are monitored. So you have a lot of data and then the average is taken. So that's the number of blows and total N value. And of course, you can see this is the energy transfer. So 4 rigs, we had almost similar kind of energy transfer, 73 to 75%. So this is one typical borehole. You can see what happens when you correct the SPT values, how much the values are increasing. And this is of course a combined plot of all the SPT values versus depth. This shows the CPT in progress, the data acquisition being done here. So let's look at the results. The cone tip resistance, the sleeve friction, friction ratio and pore water pressure versus depth, and the interpreted soil conditions. Top layer I have sand and silty sand, and then I have this clay layer down here, a sand layer again, and then the cohesive soils. So that's how the profile went. So this is the stratigraphy which has been interpreted from the CPTU, the average value. Various correlations have been developed, primarily Robertson and Cabal, most popularly used calibration. So QC and friction resistance and soil behavior type. These are correlated to various geotechnical parameters. Also correlations are available between the pressure meter measured values and the various engineering properties. Cross-hole data is also correlatable. And so using all this, you get an overall profile of how the various properties are trending with the depth across the site. So let's look at some of these interpreted parameters. This is the average QC profile. From that we have interpreted the N values. So you can see if whatever N values I am interpreting, so the actual measured SPT from the boreholes, these are in the same trend here. Similarly, the shear strength of the soil, of the cohesive soils, the friction angle of the sand layers, also gamma. Gamma, of course, I am seeing a little lower values. Probably sampling disturbance has affected the density measurements a bit. But otherwise, overall, it's a very good match. Also, you can get the constraint modulus, and the constraint modulus is used to calculate the MV value of consolidation. Similarly, the Young's modulus in the sand layers, the over consolidation ratio, the shear wave velocity, the measurements from the cross-hole seismic test has been superimposed here. You see a very good match between the CPT and the cross-hole seismic. So this is the final geotechnical profile, design profile developed from the CPTs. Now I go on to the pressure meter. This is the photograph showing the test in progress. The typical pressure meter data. As I told you, the pseudo-elastic part of the curve is used to determine the deformation modulus. The profile of the pressure meter parameters here. Horizontal stress, we measure the creep volume versus the pressure, and you get the horizontal stress, so you can determine the K0. So for design of the retaining walls, retention systems and all, diaphragm walls. Cross-hole seismic test, you can see normally you would do 3 boreholes in close proximity, and usually spaced 3 meters apart. And this shows the geophone being inserted into the borehole. Of course, this is the data acquisition. So what you get is the wave velocity, shear wave velocity, and the compression wave velocity. And then you can determine the dynamic Young's modulus and the dynamic shear modulus. So the E value, static E value, So if there are lots of correlations available, given in vowels also, and there's the Japanese correlation. Various correlations are available. Also, the CPT gives you profile the E values. Crosshole seismic test gives you dynamic E. There are correlations to convert it to static E. Similarly, pressure meter gives you the deformation modulus. If you look at this, you get such a large trend that the borehole based N value based E value is the lowest, whereas the other tests give you much higher values of E. So the higher E translates into lower settlement. So you get a much better hold on the E value. So if you can see here with the conventional SPT, you are at the lower end of here, and advanced testing technologies, so more than 50% increase in the E values. So now suppose you were to do a bearing capacity and settlement analysis. So because there are 3 basements, so the basement was planned at 12 to 16 meter depth. So we did the calculations at 12, 14 and 16 meter depth for isolated foundation 3 meter by 3 meter size, and a raft foundation 20 meter by 20 meter size. So the basic testing using the conventional IS 6403 approach, so sorry, these values are in kPa, but if you with CPT and pressure meter, you get much higher values. So the average of the advanced testing, you get 530 as against 340 here. So you can see there is a 54% increase. So as you go down, also there is quite a bit of increase in the bearing capacity and value. So there is a substantial increase in the SBC values from the bearing capacity analysis. So this is a pictorial representation. This is for the isolated foundation, and this is for the raft foundation. Again, settlement analysis we did for 50 mm settlement, although you know that for raft higher settlements are permissible. And so this way if you are comparing, what you get is a 60 to more than 120% increase in the net bearing pressure for 50 mm settlement for using the advanced testing methods. So you get you can end up with quite higher values of net allowable bearing pressure from the settlement criteria also. So this is what you are getting from the advanced testing for the 3 meter by 3 meter size foundation and the 20 meter size raft. So this is the increase you can see for isolated foundations. You are getting a 60 to 70% increase. For the raft, I am getting much more than 100%. So this means that I am going to use much higher bearing capacities, and I am more confident that those numbers are safe. Also, let us look at pile capacities. We did a calculation for 1000 mm diameter board piles with pile cutoff level at 12 meters. The trends were similar. You are getting much higher pile capacities, 76 to 86% increase in the pile capacities. So we had 26 to 32 meter long piles below the cutoff level. So this is the trend which you are getting here. So the deeper the piles are having much higher capacity. What does this translate to? It translates to money being saved. So I use higher bearing capacities, I use smaller rafts, I don't need piles because my bearing capacity has increased from 34 ton per meter square to 77 ton per meter square. So instead of using first install the piles and over that you place the raft. Here you only need a raft foundation, you don't need the piles. So if we had done the conventional analysis, I would have ended up with 200 piles per raft. And if I were to look at 5 towers, I am looking at a saving of 21 crores. Of course, the one issue was that because we are providing only raft and the water table is shallow, so for uplift we had to design some anchors, and 4.65 crores was the cost of the anchors, but still the net saving is more than 16 crores. So what we did was the client ended up spending 45 lakhs in the geotechnical investigation additional cost, but his saving was 16.35 crores. So look at that return on the investment of 3,600%. So plus in addition to that, there was the saving in construction time because you don't need to install the piles, do the pile load test, and all that is not required. We have mitigated the risks, the lesser cost of dewatering, and most important nowadays is the reduced carbon footprint. And there are a lot of other indirect savings in overheads, etc. So with this, I conclude this presentation. With a variety of in-situ tests available, modern geotechnical investigation should effectively collate data from various tests to select a realistic design profile for foundation analysis. So if you are able to characterize the subsurface properly, this can help you a lot for geotechnical evaluation of the site conditions. You get improved data acquisition, digital data processing, so you can handle a large volume of data within the same time. So the geotechnical engineer's ability to characterize the soil variability, minimize the uncertainty, and reliably predict the soil behavior, that increases quite a lot. So with better understanding of the technology, increased use of these kind of geotechnical investigations, geotechnical engineers can ensure a reliable and economic foundation. Substantial saving you can have by incorporating these advanced testing methods. Also, there is a greater reliability. You know that your foundation is safe and it's not going to fail. Now, as you know, the IS 1892 2021 version advocates use of pressure meter, CPTU, geophysical tests, etc. CPTU is now being incorporated. New code is being finalized. It should come any time now. Similarly, SPT energy transfer is also being incorporated into IS 2131. Draft code is ready and should be released soon. So it's time for us to, update ourselves, learn these new technologies, and implement these effectively for good foundation design. Thank you very much. I'll be very happy to take questions. Thank you.
Thank you, sir. Now it is the time for discussions.
Madam, there are some questions and messages.
Okay.
Okay. There are some messages. Hardik
𝗓𝗏𝗃
Yes.
Below, sir, may you elaborate limiting pressure in pressure meter test?
Okay. When you do the pressure meter test, you are actually expanding the probe inside the borehole, and that is how the failure is occurring. The limit pressure is that pressure at which the maximum pressure that you can apply becomes constant, and so you get a peak value of the pressure. I had shown yeah, so you can see here that it's become almost constant. So this is what the pressure beyond which you cannot apply further pressure on the soil. There will be expansion, increase in volume with no increase in pressure. So that is what is the limit pressure. Thank you, Dr. Krishniya.
Sir, you have excellent methods, all the methods you have. So you cannot suggest any other method to use.
I think if we can do this much, we will be able to get quite a lot of data, and you will be able to increase your design
Yes.
much better.
Yes, sir. Yes, sir. Yes, sir. And the resolution also, you get better resolution for whole area.
Number one, like this case study I showed, you could save more than 16 crores and save on the time of construction. So what more would you want?
Yes. Sir, this all, so you must be collecting data at various places, so you are preserving all the data.
Yes, sir, we have a lot of data. We have been publishing many of this data in various other forums. Also, if you will see my keynote lecture in Roorkee, IGS Roorkee, it is about ECPT, experiences with ECPT testing.
Sir, this data is actually very much useful for microgeneration studies. You have everything. You have everything.
Yes.
Mr. Sundaram, can I ask something?
Please, Dhawan sir.
See, role of geotechnical engineer, what data structural engineer needs to further design the foundation?
Sir, normally the structural engineer is always looking for what is my bearing capacity.
Yes.
Okay, so instead of giving him a lower value of bearing capacity, I give him a much higher value. Secondly, various other parameters which the structural engineer requires, like the modulus of subgrade reaction, modulus of elasticity of the soil, C5 values, all these density. So all these parameters, whatever you are looking for, I can give you a much better handle on it and more reliable value of the various numbers. So that is what is the benefit of structural engineers.
So now we have different type of foundations. The isolated footings, combined footings, layout piles.
Right.
In fact, in different type of soil, we have to recommend that this is a type of soil that is recommended for this type of sector. Am I right? So that geotechnical engineer has to recommend, no? So particular sector having 40-story building. So I mean, what type of foundation that we need, and what depth that we need. That of course the structural engineer is required, and that probably you need to assist the structural engineer.
Yes, of course. What you can tell the structural engineer, depending on the loads, the structural engineer can decide what kind of foundation is required. Like in this case study, if by conventional analysis, we would have recommended piles and piled raft. With these advanced testing technologies, we were able to justify that piles are not required. So you can go with the raft foundation. So that is how
right. So you will clearly recommend that for this structure we need this type of foundation with this much.
That's right.
Right. Right. Thank you very much.
I have a question about soil stabilization using nanopolymers. I'm sorry, number one, this is beyond the scope of this lecture. And secondly, I am not an expert on nanopolymers. So,
Sir, that question was asked by me. I am a 7th semester BTech graduate student, so I going to done a project in this topic. That's why I am asking you. I don't know about this, so you. That's why I ask some doubt on you.
thank you, Balrika. In fact, I'll be very much eager to learn from you about nanopolymers.
Oh, thank you, sir.
So whenever you complete your study, I would be very much eager to learn what you did and what you found out.
Yeah, sir, sure, definitely, sir. Thank you, sir.
Thank you.
Sir, Dr. Padmanabhan is having some queries.
Yes, thank you, ma'am. Thank you, ma'am. Sir, it was an excellent presentation. Actually, I have a few doubts. Basically, sir, this structural designers, they always go with the low SBC value for design of foundation, even though as a geotechnical engineer, even though we specify the higher values, generally they are skeptical with the higher values, and then generally they go for the lower SBC value. So my doubt is whether you have any field data to substantiate the whatever the higher SBC value arrived based on the advanced techniques or anything which is available, so that the structural designers will be using with the higher values for the design.
See, of course, ultimately it is the confidence of the designer. But all I can say is that there have been instances where these technologies have been used not only in India, internationally, and they have very much proved that what the approaches which we are suggesting, the structures are safe. Even the Burj Khalifa, the foundation analysis is similar to this only.
Okay, sir.
Burj Khalifa is a more popular and glamorous building, but there are many others. These multi-story buildings in Delhi, Bombay, and various other places in the country, whereas and also internationally in the US and other places. Robertson has been the for the last 30 years he has been pushing the these concepts and use of this kind of analysis over the last so many years, and many buildings have been built. If you will go see in literature, in fact, in Korea, in Bangkok, there are many instances where there are so many case studies you will find in literature. Now, if the structural engineer is ready to trust all that and design, that's great. But if somebody is not prepared to change, all I will say that change is the only constant in life.
Thanks, sir. Thank you, sir.
Most welcome.
Sir, Karthikeyan.
Yes, please,
Sir,
Mr. Karthikeyan. You have a question on MASW data and liquefaction potential. I have the data of SASW and borehole data at the Commonwealth Games village site in Delhi. We have published that also. If you will, I can share the paper if you want, which gives you comparison of the depth of liquefaction using MASW, boreholes and CPT. Same way we have done a lot of comparison like on this particular site also, which I had shown you. We had used the cross-hole seismic test for liquefaction analysis. By chance, there was no liquefaction at this particular site. So both CPT, borehole and cross-hole seismic test, the shear wave velocities, they confirm that there is no liquefaction. Yes.
First of all, I want to thank you, sir. Actually, I am new to this field of soil dynamics.
Right.
I was searching for local case studies, so I got all your papers from your company's website. Cengrs, so I was very much thankful to you. From that, I came to know that lot of studies you have done in India for this liquefaction analysis.
Yeah.
So now I am being new to the field. I was searching what I can do with. So I had got one old SPT data for same site. I done recently a MASWA test.
Okay.
So you for both using both I have arrived at some liquefaction potential values and some dynamic soil parameters.
All right.
But what is the problem, sir? In 1985, the site was having water table at 12 meter. Now the water table there is 40 meter.
All right.
So I have a confusion whether I can rely on this two while comparing something, or whether I can say that liquefaction potential is possible or not. So that
Actually, this is a different problem because groundwater is depleting. All of us are to blame. You know, so I have seen many sites in the northern belt where groundwater gone down from 6-7 meters 30 years back to more than 40-45 meters today. Groundwater recharge, hopefully people talk about it, nobody does it.
because literature is saying three parameters only: fines content, water table, and peak ground acceleration when you go for
That's right. That's right.
So I was trying all things, but whatever I'm doing, it is correct or wrong. That is second question.
No, what you are doing is correct. What the groundwater is doing is wrong. Groundwater has gone down too much. So if the groundwater had stayed at 6 or 7 meters, probably it would have liquefied.
Okay.
Now, when we did the analysis for the Commonwealth Games village, what we found was that because it is close to the river,
Yes, sir.
so we had the groundwater at that time when we did the investigation was at 7-8 meters.
Yes,
The client's requirement was that you take the groundwater at the ground level. I mean, there was no logic. I did not agree to that, but that was the requirement of the client, that you take the groundwater. So design for the worst condition. So there it was liquefying to about 9 or 10 meters, if I remember.
Because most of the literature it is saying that liquefaction potential assessment has to be done at ground level only. They are saying.
Whatever is the worst condition which you feel, the highest groundwater which you expect during the life of the structure.
Okay, sir.
So as an engineer, you have to estimate how much would be the highest.
Okay.
So if I do a 30-meter deep borehole and I find no groundwater, to 30 meter depth, will you still consider the liquefaction taking the groundwater at the ground level?
No point in that at all, sir. Because,
No point.
Yes, sir.
So normally what most people do in the industry I have seen is that at whatever depth you meet the groundwater at the time of investigation. So you will have to make your judgment. So suppose you were doing the investigation during monsoon.
Yes, sir.
You can consider a nominal rise of say 2 or 3 meters.
Okay.
If you are doing it during the dry season, in the hot summers, April, May, June,
Yes, sir.
then probably you should consider more.
Okay.
So everything it depends on that because seasonal variation is always there. And as far as urbanization is concerned, that is a fact of life. Next 10 years, how much development will come around and how much the groundwater will deplete.
Yeah. And second thing, sir, I am involved in some coastal reclamation works.
Right.
So the reclamation, they want to develop some island, something like that in India. And I found that 11 years I have experience. So I found when we do reclamation in some area, and some area we found that land is missing. Adjacent area. So there, whether we have to go for such liquefaction studies or what, because the groundwater table anyway it will be very high there.
Right, right.
So, but nobody is interested to do such type of studies in the such areas, coastal areas. And throughout the country, they are saying that land is missing in coastal areas.
Well, we don't have an answer to that. Liquefaction will definitely take place there.
Yes, sir. So we have to consider the studies.
Obviously, you should.
Okay, sir. Thank you, sir. Thank you very much.
Thank you. There's Mr. Padmanabhan again and Mr. George Joseph. Please, if you can, Mr. Padmanabhan.
Now, George Joseph.
Okay, George Joseph.
Hello, sir. Thank you, sir, for a great presentation. Sir, I had 2 questions. One of them was like we decided that the SPD test conducted in the case study was 73%. What is the actual steps we do to ensure we have an NCT or a different energy transfer ratio?
See, when I got 73%, so whatever N value I have, I will 73 divided by 60. So we increase the SPD value by that.
No, sir. My query was like what steps should we take to find out what energy transfer are we having at our site?
Well, you should measure the energy transfer. The equipment is available. You can so at least some 4 or 5 is for each rig. You should make a measurement. Actually, the ASTM says for each combination of SPT hammer and the anvil on which it is hitting the SPT hammer is hitting, and also the skill of the operator. That is very important. So if you were to change your operator, you would have to do the energy measurement again, unless you know that this guy is equally skilled.
So there are equipments readily available which we can install on our equipment to test the energy transfer.
The equipments are not readily available, but there are many agencies who have this equipment, and you would have to hire them to come to your site and make the measurements.
Thank you, sir. Second question, which was so in the comparison of SPC values which we received for the case study in SPT test, pressure meter test, and CPT test. The pressure meter test gave us a significantly higher value of SPC.
Right.
So is this before we apply the factor of safety, or because the variation is nearly 100.
In fact, in the conventional IS 6403 approach, we had applied a factor of safety of 2.5, and pressure meter and CPT, we had applied a higher factor of safety of 3, and still we ended up with higher numbers.
Okay. So my concern was like when we have a variation of 1000 in CPT and 650 in pressure meter test, should we assume whenever we do a CPT test, we'll be yielding a higher result?
See, let us not make generalizations.
Okay, sir.
Usually you end up with a higher SBC from pressure meter and CPT. But it is not the rule. There could be instances where your value could be slightly less or the difference is very small. So only when you do it you will know. And one thing more is that not just the higher value of SBC, we are also talking about the reliability of the SBC number.
Yes, sir.
I am more confident that my number is correct.
Okay.
So there is, you see, all engineers, there is always a tension that whatever numbers I am giving is my structure going to remain safe.
Yes, sir.
There have been instances of failure in many cases.
Yes, sir.
So I am eliminating that possibility that failure may occur because I am more confident of my numbers. So that is what it is.
Thank you, sir. Thanks, sir.
Most welcome. I don't know if there's anything else.
So, sir, I think all the messages we have covered.
Yes, Dr. Jaya.
So now we can conclude this section, isn't it? Demohan sir?
Yes, madam. Okay, madam. So please summarize.
So it is a very excellent presentation about an eye-opening of advanced geotechnical investigation, and sir highlighted the importance of advanced geotechnical investigation methods like CPTU, then SPT energy measurement, then pressure meter testing, etc. So also sir emphasized that the proper characterization of soil profile will improve the confidence in construction and it can save money and time. And sir addressed the need for upgrading the investigation methods. That is a very important aspect, such as the SPT energy measurement for enhancing the reliability of the data. So in this particular experiment, that is energy measurement, myself also have some doubts related to that. That is one of the things that one of your slides, I noticed that the SPT energy is decreasing with the depth. That is from 74, it goes to 69, 68, like that. One slides I have seen. If it goes decreasing like that, is it, we can averaging the energy, is it will be...
You have to look at the standard deviation.
Okay.
That is, if I will show you my data here, Yes, can you see that, madam?
So I think you have to share your screen.
I'm sharing the screen. Can you see it?
No, sir, PPT is not visible now.
Okay, I will try to share it again. Is it visible?
Yeah, yes, sir, yes, sir.
Yes, sir.
All right. Madam, if you will look at the bottom side here, the standard deviation is 4.1.
Yes, yes. Okay.
Okay. So obviously, every blow that you measure, there will be variation. So if we had done the one measurement at 13.1, another at 14.5, and another at 15.7. So you can look at these N values here. So all these 30 blows at 13.1, the measurement was taken and the average was 72.4.
Okay.
And same way for the others. Then all that data, so I have 36 plus 26 plus 22, that many data points. For that, the standard deviation is 4.1.
Okay, sir. Now I understood.
So I have a maximum value of 86 and a minimum value of 61.
That's why I noticed that big difference is coming in the values.
Yeah. But the standard deviation is only 4.1.
Okay, okay.
So you have to, as long as if that standard deviation is too high, that means that the SPT equipment that you are using is inconsistent.
Okay.
It is not transferring uniform energy to the anvil, which means that you need to repair that machine, the SPT system, so that you get a more consistent energy transfer. So all that earlier you never knew what is happening. So you end up with one N value and you think that is fine.
I think, sir, the code will specify that limit of standard deviation and all these things, isn't it, sir? Once the code comes.
The code, in fact, I was part of the code committee. We have not put in what should be the maximum standard deviation and all, because first of all, we thought that acceptance by the industry is more important. So right now, except for some 5 or 6 companies in the country, almost nobody has experience on this.
Okay, sir.
Now, when it becomes popular,
okay,
and I have almost every company doing this measurement, then we will be able to see what the trends are in the different places. The agencies in Kerala may be different from the agency in Punjab.
Okay.
So when we are talking about the entire country, to standardize everything is at this stage too difficult.
Okay.
So the primary purpose what the code committee felt was that let us bring in this concept and let people accept it, and let us try to see how much, what help it does, and what is the impact.
Okay, sir.
Then maybe the second revision there will be more
restrictions or more.
And when you get the feedback from the industry that this is the problems that we are facing, then maybe solutions can be worked out.
Okay, sir.
Thank you.
Then the sir addressed the wide variation, that is difference between models of elasticity in SPT and CPTU. that is a very informative, that is very useful to the geotechnical engineers while calculating the settlement criteria based, that is allowable bearing pressure calculation. So due to this, I thank sir for giving a very informative talk about the advanced geotechnical investigation, and all the participants are delighted with your presentation. I thank you sir for giving this wonderful presentation. To 𝗂𝗏𝗃 sir.
Madam, I'm greatly honored that I could make this presentation, and an expert like you was able to attend this presentation also. Thank you.
Thanks.
So thank you, Professor Jaya. So sir, I will now propose a vote of thanks. So on behalf of IGS Tirunelveli chapter, we express a heartfelt gratitude and thanks Ravi Sundaram sir for his wonderful presentation, and it was so informative. So thank you sir very much. Thank you very much.
Thank you very much.
And I thank the executive committee and all the members of IGS Tirunelveli chapter for this wonderful initiative of 𝗂𝗏𝗃. So I hope we had a great beginning, and in the months to come, I hope it will go much better. And I thank all the participants for being with us, for the wonderful interactions. Of course, those interactions also was interesting and much informative. I thank all of you, and we look forward to more interactions with Ravi Sundaram sir in future also. So thank you sir, thank you so much again, and I hope we can conclude the meeting. So good night all of you. So thank you once again sir.
Thank you very much, Dr. 𝗂𝗏𝗃. Great pleasure being with you. Anytime you call, I will be there. And Dr. Balan and the entire team, I am very thankful that you, Dr. 𝗚𝗏𝗃𝗃, all of you, really great pleasure interacting with you, and I'm sure that this interactions will continue.
Thank you sir. Thank you so much.
Thank you very much.
Thank you very much.
Thank you sir.